Hi, I'm MUHD.HIZAMI and I will present about the design and development of VR-based quick return mechanism crusher machine. This is my part where I will talk about the introduction of our project. Firstly, the project was designed to create the crusher based from the fundamental knowledge of design and mechanism by using the quick return mechanism. And this project will apply the quick return mechanism in the application of tomato crusher device, and the mechanism comprises of gears, connecting rod, slider, and current. And then the crusher uses this mechanism to reduce the human force that will use on the device later. Next is I will talk about the objective. We have three objectives in this project. Firstly is to understand the principle and can develop the tomato by using the concept of quick return mechanism. Number two is to develop the prototype based from the tomato crusher device. And then number three is to design the device by using recycled material and to capture the audience attention. Next is about the scope. The tomato crusher device will be used the SolidWorks program to create the prototype, the crusher, and do the simulation. And then we design the prototype consists of gear, connecting rod, slider, crank, supporting frame, and some of screw and bolts. Next is I will talk about the design constraint, where firstly is they have functional where the machine able to crush the tomato one at a time and also can put in a stack. And then about the safety, where we will use the physical energy by people or human, and then it's suitable use in the household applications. Next is about the quality. It can do the work more efficient and use less energy. Next I will talk about the economic, where is under the budget of RM70, and then I will talk about the life cycle, where the running hours depends on the people energy, and then the life cycle is estimated around I think 2 years. Next is I will explain about the quick return mechanism, where quick return machine is short of mechanism that convert rotary motion into recuperating motion at a different rate depending on the stroke. Cutting method involved hand tool and crank during early 19th century, where often lengthy in procedure. Luckily in the mid 1800, Joseph Whitworth changed this by creating the quick return mechanism. By using kinematic, he determined that the force and geometry of the rotating joint will affect the force and motion of the connecting arm. This mechanism is a common feature in tools or machinery that perform its action in only one direction, for example, shaper, screw press, and power driver show. And then the quick return machine consists of linkage. This linkage has the string as well as weakness. Next, I will explain about the literature review, about the introduction, where the tomato crusher device takes a lot of knowledge and understand to make the prototype of the device. The construction and certification of this tomato crusher project were from the information that obtained from the research. Without the research, the construction cannot be done because of the lack of understanding of the crusher. So I will talk about the terminology of our project, where the tomato crusher, a crushing device that can crush any fruit or vegetable, but it depends on the size. It's typically used in the household, where the daily use in community. And then the tomato crusher can be used by any person because of the feature that easy to use and not complicated. It also an tool that can crush the tomato in convenient way. Next, I will talk about the quick return mechanism for the literature review. Firstly, quick return machine is a sort of mechanism that converts a rotary motion into recuperating motion at different. And then the machine is called quick return because of the time taken for the work stroke to finish is longer than the return stroke. From an engineering standpoint, the quick return mechanism impacts the technology of the industrial revolution by minimizing the duration of a full revolution, thus reducing the amount of time needed for a cut or press. Next, I will give to my team. That's all from me. Thank you.
Okay, hi guys, I'm THARUNAN. Okay, I would like to explain about the methodology part. Okay, welcome. I'll start from the introduction, where methodology is an essential element in a project as it assists students so that they can complete the task according to the scheduled plans within the times provided. The main aim of this project is to design and develop a tomato crusher that environmentally friendly and low time consuming machine. Okay, this is the flow chart you see. Okay, we'll start, then specify requirements, then brainstorm ideas, design and analysis, then CAD design develop, then CAD simulation, then if modification is required, then we go back to the CAD design development to develop what is the error and thing, then develop prototype testing, then acceptable or not. If it's yes, then straight to presentation and end of the project. So now is the design and prototype development. Okay, if you see in this project, the main design of the crusher machine were already given, but in need of development. Design development is then selected from the several sketches, and the design details are improved. The final of the best sketches that has been chosen will be drawn with computer-aided software called CAD, which use the SolidWorks app, and to produce a virtual prototype for this project. Okay. So you can see this the concept, where this is the concept of our project. In this concept, it does satisfy the minimum requirements of having at least 2 gears and applying 4 mechanism gear. Okay, you can see that this is the prototype. And this is the material selection. The table below shows the selection of material that have been done to design the tomato crusher. Like you see, first of all, gears. The gears we've done by doing the 3D printing, and it's cost about RM 48 ringgit, and steel frame is cost about 8 ringgit, and bolt and nuts, plywoods, sticks, and we use hot glue gun for extra support, and super glue, PVC pipe for the gear support, and wooden crusher. And total estimated cost for this project is around 72 ringgit. Okay, and this is the gear. Okay, a gear is a toothed cylindrical or roller-shaped component of a machine which measures another toothed cylindrical to transmit power from one shaft to another. It is mainly used to change in torque and speed of driving shaft and driven shaft. Okay, and steel. Steel brings numerous benefits such as high strength of material, yet most importantly, steel in known of its sustainability structure. And structural steel is most recycled material on our planet. Availability of steel nowadays mark the steel industries around the world. Okay, and crushing frame. So you see, crushing frame is the place where the crushing occurs. In this project would have been used to design the crushing frame. Okay, design and analysis. Okay, design analysis is essentially a decision-making process in which analytical tools derived from basic science, mathematics, statistics, and engineering fundamentals are utilized to develop a product model that can be converted into an actual product. In this project, the analysis section is mainly on calculations related to the system. So several formulations to determine some parameters in the particular of the system are needed to obtain desired information. Okay, power used in the tomato crusher. See, in this project, we use the human power extended by our arm. So it's a manually, and the produced power were estimated between 1 or 0.5 because the normal people usually can produce power around 0.5, and the torque of the human force is 5.3. So this is the table where we have the forearm and the torque power used. Okay, now we go into the calculation part. So the RPM of human arm force, so we see we have the calculation 0.5 times 5,225, then divided by 5.3, and you get the RPM of human force. Then the rated power is 0.5 times 0.746 equal to 0.373. So the design power, you we get a total 0.4476 kilowatt. And the angular velocity we get a 52.67, and the force, and we calculate the force which are torque divided by radius length, and therefore the maximum force produced is 17.67. And the gear ratio where we have 12 teeth to 24 teeth, and the first is 503 RPM and the second one is 252 RPM. So the velocity ratio is 24 divided by 12 is 2. So its ratio is 2 to 1. And speed of gear 0.03 divided by 2 is equal to 251.5 RPM. So pitch diameter therefore is equal to 1 divided by 0.16 over 24 is 150 meter. Then center distance between the axis of the rotation gear, which is 0.12 meter, and the circular pitch is 0.021 meter. And torque, angular velocity and power on gear analysis. So angular velocity you can see is 52.67. So assumption of force to crush a tomato in 100 Newton, which does not exceed the maximum of force 17.67 produced by human force. Therefore, the torque is 30. So power input is 26.3 volt. So for driven gear, the angular velocity is 54.61 meters per second. So assumption of force to crush a tomato. So we get the torque, so which are force times radius, so it's around 20, and the power output is 18.2 watt. Efficiency, you can see this 18.2 divided by 26.3 times 100, so it's 69.2%. Okay, that's all from me. Now I'll pass to my groupmate for the next swap design. 3.
Hi, I'm LOHENTHIRAN Sankaran, BK17110131, and my part of this project is the discussion and the designing part. Okay. Regarding the discussion part, the gear ratio obtained was 2 to 1, and therefore the speed of the gear was 503 revolutions per minute. And it is found that the speed of the gear was comparatively high. Besides that, the part that was used to construct our tomato crusher was gear, hub, crank slider, crusher, crushing frame, bolts and nuts. A gear was used rather than a spur gear. As a result of a gear includes a drive efficiency up to 95th till 98, and low maintenance costs, don't need parallel shaft, load fluctuations are shock absorbed that will increase the machinery life. The slider crank was chosen as a result of its permits of a slower forward stroke of the slider to and a quicker return stroke that permits use less effort done to crush a tomato. For the bolts and nuts, it has been chosen over rivets as the result of its permits high clamp load is created just by turning the nut and bolt. Is removed quickly and simple using normal tools. Besides that, it is reused, quick and easy installation, and normal handheld tools are spared to put it in. To develop this project, a really low amount of money was used, which is only 70 ringgit. The limitation of our project is that just one tomato can be crushed at a time. But using some R&D, we can develop this project by using a motor, and it can be commercialized for company users to make things like tomato sauce and so on. We then saw a number of issues that we encounter while conducting this project, and one among it absolutely was to extract the gear from a 3D printer. You can see that our gear, we use a 3D printer to print all 4 of our gears. Other than that, we tend to also face difficulties in putting the gear aligned inside the holder and putting the driven gear on the steel stand, which you can see over here. Moreover, the work progress took around 9 weeks, where we completed every single part with dedication. Not solely that, we tend to work as a team that consists of 3 members, which is the previous presenters just now. We tend to went through heaps of hustle in order to finish the project, which was difficult in looking out the appropriate material needed for the prototype, critical thinking in modifying designs, sketches, and difficulties in maintaining a continuing commitment functioning on report and project. Work was sole key for us to finish this project with success. We've gained heaps of experience as we tend to successfully create a tomato crusher, which you can see now by our own. So for the conclusion part of this project is, while this experiment was applied, we managed to find out a couple of parameters that was given importance while coming up with the tomato crusher, which includes the design consideration, the design calculation, and choosing the material that are appropriate for the project. We've achieved our objective of the experiment, which includes the design and invention of a tomato crusher using primarily recycled materials, and a tomato crusher was developed using a conception of fast return mechanism, that is the slider crank mechanism. We successfully achieved our drawback statement wherever the perfect time needed for return stroke was reduced. To sum up, we've additionally achieved the project outcome that was given to us. For the recommendation part, we can enhance the performance of the tomato crusher by using few modification and recommendations. To ensure constant amount of force applied to the gear which crushes the tomato, a DC motor should be used as the power source. To make the tomato crusher more efficient, a motor can be used because it is very low maintenance cost and it is easier to control. And number 3, to be used for longer lifetime, solid metal should be used, replacing the woods which make it a heavy duty machine. A commercializing potential is the working principle of the tomato crusher is extremely honest to goodness. The tomato is first placed in the compartment provided. The gear is then turned manually, permits the tomato to be crushed. As a simple to handle a tomato device, it's also simple to commercialize the machine because it's very eco-friendly and user-friendly. Since we've designed the tomato crusher using recycled things, it's low cost of production where it's high commercialization potential. So this is the design that I've made through SolidWorks version 2017. That's the isometric view of the machine. This is the top part, this is the front part, and this is the right side part. That's all from me. Thank you so much. Okay, you can see this is the prototype machine that we have produced through all the hard work from all my teammates. Okay, you can see that we have produced the 3D printed gears here, and we connected it with the shaft, and this is the holder where the tomato goes inside here, and you can see this is the crusher connecting this gears which will crush the tomato inside. And you can see from this design itself, it's a very low cost, and we used all the things, most of the things from recycled materials only. Okay, this is the holder. We need to pull and push so that the crusher inside the box will go inside and crush the tomato. Okay, for this model, we can the recommendations which I suggest just now, we can put a motor in here, and we can reduce the volume of space inside here so that the machine will become more efficient. Okay, now we will see how the tomato is being crushed in this machine. First of all, my friend will put tomato inside the hole here. Okay, now we just need to pull this lever so that this gear mechanism work in order to push the block inside. Okay, now you can see that I am just pulling the object here, and you can see the tomato is being crushed. Now you can see the whole tomato has been crushed. So we can see that